Hi there, my name is Dave OudeNijeweme and I'll be presenting together with my colleague John Regnart the Automotive Council roadmaps to you today. So the roadmaps, as previously, consist of the light duty vehicle roadmaps, the heavy duty vehicle and off-highway roadmaps, as well as the bus and coach. They have had a significant update. Also, we'll be presenting the technology roadmaps to you, so the battery one, or the e-machine, power electronics, and the TPS. On top of that, we have lightweighting and a totally new roadmap around fuel cells. But first, we need to start with a health warning. So the roadmaps are global roadmaps for what industry thinks at the moment is going to happen in the next 10 to 20 to 30 years. They are not a forecast and really therefore can't be used like that. But they are a guideline of what technology might come out and where we should prepare to go next. So today we'll talk you through, of course, the roadmaps. We'll be talking to you about why we're doing them. We'll talk to you about how we're doing them and how we build that consensus. We'll talk about the trends and drivers that actually spur on the roadmaps and the changes in technology and how that is brought about. We then have a different way that we link product and technology roadmaps, and we'll take you through that before really going into some depth around the new 2020 roadmaps. And then right at the end, if you want to know any more, we'll have question and answer sessions afterwards and the link to the roadmaps themselves. So why update the roadmaps? Well, apart from the last time we did it was in 2017-18, so apart from time having marched on and things have moved on significantly, we have found that the roadmap has been very influential in quite a number of different areas. They've influenced industry, they've influenced government spending, and also across the sectors they've had some significant influence. So we thought it was prudent to update them, but don't take our word for it. We ran a survey, and from that, a significant number of people found it quite useful. There are a number that don't find it that useful, so clearly there is some room for improvement, and that's what we tried to incorporate this year. So what we have seen though is that there is a real need to update these roadmaps because there is now a number of other government incentives going on, and I think roadmaps, with knowing where things are going to go, will significantly influence where money is being funded. Funding is appropriately spent in the right sort of areas, and the roadmap is a guide to help with that. And that's why it was appropriate to have a fully updated set of roadmaps this year. I'll now hand over to my colleague John Regnart, who will explain a little bit about how we build consensus through industry and academia players. Over to you, John.
Thanks, Dave. Hello, everyone. My name is John Regnart. I'm the Automotive Trend Strategist at the Advanced Propulsion Centre. And in this part of the presentation, I'm going to take you through how we built consensus through the automotive industry and discuss some of the trends and drivers. The key to the Automotive Council roadmaps is building a consensus. They don't represent the APC's view, they're your roadmaps, and they represent the automotive industry's at a particular point in time view. So as you can see from the graph on the left, we've had a range of different stakeholders engage in workshops and one-on-one interviews. These range from high-volume OEMs to low-volume OEMs, large tier one suppliers and innovative technology developers, as well as trade bodies and academia. To complement the interview process and the workshops, we also completed an online technology survey. 99 of these were completed, and 60% of the responders from there were from senior people in industry. And we had a really good spread of organisations across the value chain, ranging from vehicle manufacturers and their suppliers. We'd like to thank all of the people who took part in the workshops, took part in interviews and completed the survey. As I said, these are your roadmaps and we couldn't have updated them without people's help. So now that I've established the consensus building process, I'd just like to talk now a bit more about content and the trends and drivers that are driving the automotive industry. So when we published the roadmap report in 2018, there were 6 key trends and drivers that we identified. These range from tailpipe emission legislation to the wider energy system and life cycle regulation. And through consultation with industry, we realised that these still largely hold, but things have accelerated so quickly that we need to properly define how these will evolve through time. So examples of this are the UK and the EU committing to net zero economies by 2050, which accelerates development of technology. There's also, with this acceleration, debate around resource use and the ethical and environmental concerns around the use of these strategic resources for batteries and e-machines, and other debates around vehicle efficiency and the phasing out of certain types of vehicles. So on the screen in front of you are the drivers and regulations for light duty vehicles under 3.5 tonnes. And really we can categorise these based on those 6 different trends and drivers. Starting with tailpipe emissions, this can be broken down into CO2 emissions and pollution and resource. So CO2 emissions is the tailpipe emission regulation that we see today, and air quality regulation for that we have through Europe. And again, these exert influence in the short term. Then there's localised regulation, which take the form of zone regulation and ZEV policies. So zone regulation refers to emission zones, and this transitions into vehicle entry restrictions, and pedestrianisation of urban areas is a really good example of future trends in zone regulation. And again, for ZEV policies, we see that a localised approach to ZEV mandates, looking in California and China. We expect in some areas this may be adopted, and European nations are already looking at ZEV mandates. Then we move to life cycle regulation, which is given a lot more prominence in these roadmaps. Things like net zero CO2 and holistic environmental impact legislation start to bite a lot earlier than we had anticipated in 2017 roadmap. And other trends like the wider energy system are reflected more in the detail of the roadmap, but we've mentioned it in the trends and drivers for EV efficiency. Connected and autonomous vehicles and mobility as a service is given space through urban mobility, through discrete transport services. So you pay for an Uber, or you pay for a bus, or you have a monthly payment in your car. And that transitions to on-demand integrated transport services, where you basically just pay monthly to use mobility in a city area. So those are the trends and drivers affecting the automotive industry. I'm going to hand back to my colleague Dave to talk about how the product and technology roadmaps link together, and also to give some more details about the heavy-duty vehicle roadmap.
So, as we said, we have a slightly different way of linking product and technology roadmaps this time round, because we have realised that in 2017 we were quite good at looking at what the trends and drivers were, moving that to products, and it was quite swift to understand where the technology would then go. However, now in 2020, with the changes, the fast changes that we have in mobility services and how mobility is being consumed, how transport is being consumed, but also a plethora of different technologies being available and being viable, they have a bigger influence, or will have a bigger influence and exert that influence over the products. So we started sort of linking the two a little bit together. And one way of doing so was, we thought, by mapping them out on a power and energy axis. And if you do that, for example, for light-duty vehicles, where energy is an idea of range, of the amount of energy that you need to have on board to make a particular journey, and power is the amount of power that you need to actually propel a vehicle, we sort of mapped this out for all of the products, but here is the example for light-duty in particular. And you can see that from the industry feedback that we had, is that there is a nice, fairly linear line. Obviously there are things that don't necessarily fit that profile, but that effectively gives you the rule that there is in play. So this is how we went about this, and this is how we're linking technology as well as products together. So what does that then look for light duty vehicles? And light duty vehicles in this case is passenger cars as well as light commercial vehicles up to 3.5 tons. We sort of group them into urban transport, then an element which is more long range, and then the high performance, very long range, sort of exceptionally high performance vehicles in there as well. And you can see there is a low power, a medium type power, and a very high power element to that. And there's a bunch of sort of vehicles that fit within that particular category. So again, going back to the power versus energy way of looking at things. So what you see here is of course the bus and coach. We have light duty vehicles on there up to 3.5 tons for commercial vehicles, and then heavy duty and off-highway elements in there. So they effectively have that trajectory from the left bottom corner to the right top corner, and we put some examples on there that you might be able to see on here, just as examples. And of course they operate in an area, not just one particular spot. And we'll talk you through to some examples. And the first one that I'll take forward is one for heavy duty vehicles and off-highway vehicles. So long range heavy duty vehicles and off-highway, this is the new roadmap for that. And as you can see, for the first time, we've really taken into account the fuel elements that you see at the bottom of it. So, the energy choice will start dictating what might actually happen. So we're taking that into account. But also I would like to talk to you about TPS, so internal combustion engine and old money, and how we see that moving forward with renewable fuels. But also I'd like to talk to you here about fuel cells and how that might transition into this space. So let's start with off-highway vehicles. And I think here it's really important to realise that the choice of propulsion is guided primarily by what fuel, what energy is on site, what's available on site. And at the moment, of course, this mainly is driven by diesel engines. We think that in future, with the right amount of sustainable fuels, that this industry can go to net zero. And that's why we looked at this as TPS. Of course, with hybridization, without hybridization, that's just an efficiency measure, but with the sustainable fuels you can get to net zero, and that's what we're looking for here. So we'll pick out some interesting elements of that, but if you think about heavy duty off-highway vehicles like that, it is around efficiency, it's around elements like that to get to net zero, and fuels is certainly one of them. So the elements that I'd like to pick out here are so efficiency improvements, specifically on thermal efficiency, and the community things with the thermal propulsion community thinks that the efficiency can be significantly improved over and above the engines that we have currently, purely on thermal efficiency. On top of that, we'll see hybridization, which as a system will then further increase the efficiency of the whole system, of the whole vehicle. And we still see that there is a lot of mileage still to be had in that. So we also then state that if you want to go to net zero, sustainable fuels, net zero fuels are an absolute given. And we do think that is a possibility, and certainly the community thinks that's a possibility. The other thing I'd like to point out is sort of AI-enabled efficiency improvements, and our colleagues at the IDE, they are doing the digitalisation roadmap at the moment. They've just done before, and that's an element where you can see the overlap happening between the roadmaps here, but certainly what other industries and other sectors and other elements bring to this roadmap. The other thing that I'd like to talk to you about briefly is about long-range on-highway trucking. It's been reported quite heavily that fuel cell seems to be an obvious answer. It is one of the answers, as we've highlighted here in this roadmap. And the one element that a number of elements that I like to pick out to this one before we move on to the fuel cell roadmap is that before fuel cells are ready to go into this sort of transport, they need to have longevity, they need to be robust, and they need to be efficient, because basically this industry works on a total cost of ownership model, and on that basis they need to be cost effective. So the fuel cell are best summed up, I think, in the targets that we've set. The targets are primarily around cost, cost of the stack, cost of the system, also cost of the tank. They are different between light duty and heavy duty to express the difference in what's important to that particular product. Heavy duty, of course, is very much focused on total cost of ownership rather than the cost of making the product itself. And that's what we've highlighted here in the fuel cells and the target setting, or the guidelines that we see, or key indicators that we see going forward. And they are set out very clearly in the roadmaps. So with that, I'll hand back over to John, who will talk to you about light duty vehicles.
Thanks, Dave. So Dave's given a really good overview of the heavy duty and off-highway vehicle roadmap. So what I'm going to do is dive into some examples of vehicle types from the light duty vehicle roadmap. Is the light duty vehicle roadmap, and I'm going to pick one vehicle type from each of the three categories. So I'll pick a low power BEV for urban mobility, a hybrid for long range mobility, and I'll pick a high performance BEV for the high power performance section. So the first vehicle I'm going to talk about is a low powered BEV, and on the screen there I've got an example of the Citroën Aiming, and this typical vehicle represents a design shift and a new class of electrified vehicle. Its battery capacity is low, its voltage is low, and the motor size is relatively low. And potential future trends for the technologies in this sort of segment are low cost battery chemistries, lower voltages, which means silicon's probably more likely to be adopted, potentially GaN if the costs are low. Could potentially be vehicle to grid ready with some wireless charging. And again, the options for motors is quite diverse. There could be induction for cost, in-wheel motors for responsiveness and package space, or permanent magnet motors for high power densities and small size. And if we look at the technology roadmap, so on the screen here is the cell materials and manufacturing roadmap. We see that reduced cost lithium ion cathodes is a potential avenue for this type of vehicle segment, and that shows increasing improvements in lithium iron phosphate, and then transitions to ultra low cost cathodes, which could be potentially sodium ion or manganese rich lithium ion. And again, for anodes, this could be power dense lithium ion anodes to handle high charge acceptance. Because the range is low, it needs to accept charge quite quickly. And again, if we look at the lightweight vehicle and powertrain structure roadmap, we'll see mission suited lightweighting a key theme on the design led side. And again, we've put this in specifically to highlight those types of vehicles so that are connected and autonomous vehicle adopted. They have minimal crash structures and designed for urban mobility. The second type of vehicle type I want to talk about are hybrid vans, and the typical type of application here, they cover, it's in long range mobility, and these could be a transit type of application that covers long distances. It goes in and out of emission zones, or has a very sort of long duty cycle, and it's a mixture of the best elements of the engine and a battery pack. And the future of this, as Dave mentioned, heavy duty is very much around thermal efficiency, but in this light duty segment, it's all about system efficiency. So dedicated hybrid engines that maximise the use of the engine at a certain peak operating point. They'll have sophisticated geofencing that enables emission zone compliance. But just to reiterate again, for what's needed for ICE to continue in the long term is that we need net zero sustainable fuels to continue in this segment. And again, this is reflected in the thermal propulsion system roadmap. So looking at the light duty orientated, it's dedicated hybrid engines are a key theme there. And in the engine control systems, we've got increased geofencing as a trend. And as well, in the drive chain systems, we've got dedicated hybrid transmissions, which shows the trend towards optimizing the electric motor, the engine and the transmission system to optimize vehicle level efficiency, not just optimizing the individual components within the system. And finally, I want to talk about high power and performance vehicles. And these, in particular, I want to talk about BEVs. So an example of a vehicle here would be a Porsche Taycan. So it's a high battery capacity, very high power, and operates on 800 volts with a long range. And the type of attributes we could see in this vehicle segment is both high energy and power density chemistries, which would make it more likely to adopt next generation chemistries like solid state. The higher voltages enable the benefits of silicon carbide to be realised, and it will need new converter designs to enable fast and wireless charging. And it has more breadth for high performance motors to be commercialised in this sector, with aggressive cooling needed for high speeds, high performance winding and enhanced magnetic materials. And in the electric machines roadmap, we highlight the approach for advanced architectures, direct liquid cooling for enhanced thermal management properties, and better materials through copper, enhanced E-steels and enhanced magnet manufacturing. And then we move to the power electronics roadmap. Again, for these types of vehicles, we'll see wide bandgap materials such as silicon carbide, especially for the high voltage and high power elements. And again, new package designs for these wide gap materials will be needed. And again, we see functionally integrated drives such as that have shared cooling, shared housing and embedded electronics to get higher power density inverters and electrical machines. So that's some of the themes of the light duty vehicle roadmap and how we can link the product roadmaps with the technology roadmaps. I'm now going to hand over back to Dave to summarise and how you can see the new roadmaps.
So just to summarise the roadmaps here, what we see is that automotive technology is changing faster than it's ever done before. And I know that's often said, but really is the case. What that means for us here in the roadmaps is that the trends and drivers now need to be pointed out quite clearly in where they fit into the roadmap. So they need to be defined and need to be very prominent. The other thing that we see is that a number of different technologies are more viable and therefore will exert a bigger pressure over what the products might look like. And therefore we connected technology and products in a different way, so you can cross-reference things and cross-match them. So I think that's a significant change. Thirdly here, I think we need to talk about life cycle and life cycle assessments, because we think that will supersede or at least complement what we've seen so far around tailpipe emissions. And the roadmaps cover these. They talk about sustainable fuels and net zero and surely the energy that's required to propel the vehicle. But it also includes some of the production elements and the carbon intensity of those. And they are captured in these particular roadmaps at a high level. The rest of the summary is around the heavy duty and off-highway roadmap. Product roadmap is significantly enhanced this time round, and it shows a very diverse set of options, and I think that's significantly different from 2017. We also have the world's most comprehensive automotive fuel cell roadmap now incorporated in here, and I think for that we had very high quality and very significant actors globally that inputted into this. I have to finish off on saying a big thanks to the Department of Business, Energy and Industrial Strategy for helping us to do this, allowing us to do this. Of course, the Automotive Council, which these are the roadmaps for, they have been very supportive, and of course to you, all people that have contributed to these roadmaps. Without you, this wouldn't have been possible, and it would certainly not have been as good as this. So if you would like to know more, well, I will be here and I'll be joined with John, of course, and also our colleague Bhavik Shah, who's been instrumental in delivering these roadmaps. And also we will have these roadmaps available on our website. And so please do go in and we'll meet you for the Q&A straight after this. So thank you very much from me and from my colleague John Regnart. John, give us a wave.
Thank you everyone for listening.
Thank you and see you later. Cheers. Bye-bye.